right, so now that we've written the essential question, let's talk about what are the postulates we use to prove triangles congruent. First question is, what is the SSS postulate? And that would be the side, side, side postulate. Go ahead and write that down. And then let's fill in some more of this definition. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So let me open this up a little bit. Let's see how this looks with two triangles. If I know that side AC is congruent to XC, and that CB is congruent to ZY, and that AB is congruent to XY, then I can say I've got a proving mechanism that by the side, side, side postulate, I'd have two triangles congruent to each other. And let's write our congruency statement. Let's see, we'll start with triangle ABC, so I'll put those three letters in order. And now let's find the path we took to get from A to B to C and make sure that we follow the same one on this triangle. From A, I crossed 3 marks, hit B, and then crossed 2 marks and got to C. In this triangle, I'm going to start at X and cross 3 marks to go to Y, and then cross 2 marks to get to Z. So by the side, side, side postulate, triangle ABC is congruent to triangle XYZ. And with these postulates, a lot of times I'm going to say out loud or say to myself, side, side, side. I have 3 marks here, 3 marks here. They correspond to that specific postulate. And that helps me know which one to choose because we have several more to talk about. All right, make sure you have all that written down, and then let's scroll down to the next part, our next postulate. Okay, so the next question is, what is the SAS postulate? And it is the side angle side postulate. Go ahead and write that down. Pause the video if you need to. And then let's fill in some information about our side angle side postulate. So we have, if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. All right, so just like with our SSS postulate, let's take a look at what this looks like with two triangles. So I'm going to, let's see here, start with, if we know that if side DB is congruent to side RP, and we know that angle B is congruent to angle P, and we know that BC is congruent to QP, then we can use the side angle side postulate to prove two triangles congruent. And this is important. You can see this angle here, B, is in between the two congruent, or the two marked sides, for lack of a better term. And in this case, the same process, right? We've got 1 mark, an angle, 1 mark, and then 2 marks. 1 mark, angle mark, 2 marks, 1 mark, angle mark, 2 marks. Again, that angle must be the included angle to use this postulate. So I would say by the SAS postulate, I have triangle, and we'll do this in order, I guess, triangle BCD is congruent to which triangle? What are the letters we're going to use? Well, let's take a look at our path. We went from our marked angle across 2 marks to get to C, and then from C to D, there are no marks. So it's from marked angle, 2 marks to C, across no marks. So I'm going to start here with P. I'm going to cross 2 marks to get to Q, and then no marks to get to R. So again, the path matters, and the letters matter in the order in order to show pure congruency by this particular postulate. All right, make sure you have all that written down. Pause the video if you need to, and then flip to the back of the page. All right, so let's take a look at a couple of examples of what we're looking for here. Let's number these 1, 2, 3, 4. And I'm going to start with number 1. I have what's going on here are two conjoined triangles. They are conjoined by what we've called a shared side, and we need to mark our shared side. I'm using 3 marks because 1 mark has already been taken up with these 2 sides. 2 marks were here and here, So I need to move on to a third mark to again show that these two, or this side itself, acts as a shared side. If I were to break these two triangles apart, this third side would actually share the same value between both triangles. So I'm going to look and see I've got 1 mark, 2 marks, 3 marks, and then 1 mark, 2 mark, 3 marks, or say to myself side, side, side. So I would say yes, are they congruent? Yes, by the side, side, side postulate. That's a B. For number 2, I have 2 sides marked congruent, and there's nothing else marked, but I have this thing called a set of vertical angles going on here in the middle that we've learned about and discussed for weeks and months at this point. And so in this case, I'm going to kind of walk around my triangles, and I've got a side, an angle, and a side, or a 1 mark, a mark, and then 2 marks, 1 mark, mark, and 2 marks. And so again, I'm kind of thinking to myself as I walk through the markings and the path I'm taking to say that I can use that, yes, they're congruent by the side, angle, side postulate. Again, it's the angle's got to be in between these two guys in order to use this one. Go ahead and pause the video and try numbers 3 and 4 and then check your work. All right, and you should have gotten these two answers for numbers 3 and 4. If you didn't get that, would you please raise your hand and we will come and give you a hand. All right, let's move on to our next postulate, which is the angle side angle postulate. What is the ASA postulate? And I'm just going to scroll up a little bit. It is the angle side angle postulate. Make sure you have that written down in your notes. And here we have if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then the triangles are congruent. So in the case above, or on the previous one, we had an angle included. Here we have a side included. So let's see how this looks. If I know that angle A is congruent to angle D, and I know that AB, side AB, is congruent to side DE, and I know that B, angle B, is congruent to angle E, then I can say that by the angle side angle postulate, I have 2 triangles congruent, and let's go ahead and make our congruency statement. Triangle ABC is congruent, and again, let's follow that path. We went from 1 mark across 1 mark to B, or we started at A, which has 1 mark, across 1 mark on the side to get to our 2 mark B, and then finally to C. And so we're going to do the same path on this triangle, from D across 1 mark to E down to F. So D, E, F. Oop, and I made this one easy, I suppose. All right, so let's just scroll down here and move on to the next postulate, which is the angle side angle postulate. Go ahead and write that down. The question is, what is the ASA postulate? Again, angle side angle. And let's make some notes on what that really means. We have if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, and the triangles are congruent. So just like above, we've got an included situation. Above we had 2 sides with an included angle. Here we have 2 angles and an included side. So if angle A is congruent to angle D, and side AB is congruent to side DE, and angle B is congruent to angle E, then we can use, or we can say that by the angle side angle postulate, we have 2 congruent triangles. And let's go ahead and write our congruency statement. I guess I'm cheating a little bit by going in the order of the letters. But nonetheless, let's see how the path looks. We have 1 marked angle at A. We go across 1 marked side, hit B, which is 2 marks, and then go to C, which has no marks. Down here, we have 1 marked angle at D. We go across 1 mark. We hit 2 marked angles at E. We go across no marks and hit F. So we can then say that those 2 paths match, And we have congruency of those two triangles by the angle side angle postulate. All right, so make sure you have all that written down and then go to the next page of the notes, which brings up, what is the AAS postulate? The angle side angle postulate. Make sure you have that written down. I mean, this is all, I'm assuming, making sense to you guys. Angles and sides. In this case, let's see how this looks. We have if two angles and the non-included side, or a non-included side of one triangle are congruent to two angles and the non-included side of another triangle, then the triangles are congruent. So we need two angles and a non-included side. So let's see here. Let's start with Q. Q and C are congruent to each other, and B and P are congruent to each other, and let's say BD and RP are congruent to each other. Then by the angle side postulate, we would have the following congruency statement. Now keep in mind, I'm randomly choosing angles to show congruency. Okay, these markings are going to be presented for you unless you have to show you have a vertical angle like we saw in that example. But the goal with this lesson is to be able to see the path of the congruency in the markings and then apply the postulate that you've learned to it. So again, by the angle side postulate, we've got triangle BCD congruent to what? All right, so the path I took was from B to C to D, and you can see I've got 2 marks here crossing nothing, 1 mark here crossing nothing to get to D. So this path you will be able to find in the next triangle. And so let's find it. We went from 2 marks at P, like 2 marks at B, so 2 marks at P to Q, cross nothing to get to 1 mark, and then from Q to R to get to nothing. So our congruency is going to be triangle BCD is congruent to triangle PQR. Right? These paths are sometimes a little more challenging to follow, but you will see the exact same path in both ones or both triangles. And as long as you're hitting all of the same markings as you go, you're going to be fine. All right, so make sure you have that written down. And we will get to the final postulate for congruency. All right, let me roll this up a little bit. What is the HL postulate? We have the hypotenuse leg postulate. The hypotenuse leg postulate. All right, make sure you have that written down. And so it's if the hypotenuse and one leg of a right triangle, and I highlight right, are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So here's a right triangle because he's got one right angle, and let's make sure we understand what these terms are. These are the 2 legs. Okay, they are the sides that have the included angle is the right angle. And then there's our hypotenuse. And I always like to take that right angle mark wherever he is and make a little path over to my hypotenuse. Throw a little H on it to make myself feel better to know that's my hypotenuse. And so as long as I've got the hypotenuse and one leg and the triangle's right, then I've got myself a congruency postulate to use to show congruency. So let's take a look at how that rolls here. We've got some conjoined triangles. They're conjoined with this side, and as I always like to do, let's make sure we mark our shared side. I'm going to put 1 mark there because there's no other markings on our sides. We've got right angles, okay, here and here in each of our triangles. And so now if we know that our hypotenuse is trying to figure out the plural for hypotenuse, if they are congruent. and the one leg is congruent. That is enough information for us to determine that by the HL postulate, we have triangle WXZ congruent to, let's make sure we know the path we took. From W, we crossed 2 marks, hit X, cross 1 mark, hit the right angle at Z. So we'll do the same thing over here. We'll go from Y, cross 2 marks, hit X, cross 1 mark, hit the right angle at Z. Okay, so that's our congruency. And we have, again, 5 postulates that we'll be choosing from. Let's look at a couple of examples before you guys go to do some work on your own. We have here, for each pair of triangles, tell which postulate, if any, can be used to prove the triangle is congruent and complete the congruency statement where requested, because not all of these are actually showing letters to use to show. So I'm going to walk through 2 of them, and then I'm going to have you guys try the other 3 on your own, and then you can check your work. So let's take a look at this first one. Incidentally, the question says, tell which postulate, if any, because there's going to be some distractors out there where there's going to be some markings that do not let you show you have congruency. And that's okay. In those situations, you're just going to write none next to it or not congruent. So in my first example, we'll call this number 1, and then I will walk through this one as well with you. We'll call that number 2. You guys can work on 3, and we'll put a little 4 over here and 5. Okay, so on number 1, we show some markings already. Let me just reiterate these marks. Here's a mark, here's a mark. This is an angle D is congruent to angle B. Okay, that's not 2 marks, just kind of trying to re-show you guys what you guys should see on your sheet. In addition, I've got a set of vertical angles. So just like in our exercise we did where we were marking random information, I'm going to mark these 2 angles with 2 marks since 1 mark was already taken up between D and B. And then I'm going to take a look and see if I have a path to show congruency. I've got 2 marks here at C, and looking at this triangle ABC, 2 marks at C, 1 mark at B. Let me make this prettier. This should be 1 mark. Losing it. This should be 1 mark. Okay, so C has 2, B has 1, crossing 1 mark on my side, I get to A. Over here, I can go from C with 2 marks, D has 1, crossing 1 mark on my side to get to E. So if I said it out loud, I'd say angle, angle, side, angle, angle, side. So by the angle, angle, side postulates, I know that triangle BAC is congruent to, and let's find the path based on the letters they have in order, B, cross 1 to A, get to 2. So I start at D, cross 1 mark to get to E, and then hit the 2 marks at C. So that would be my congruency statement for number 1. For number 2, I have what looks like a right angle mark here, and of course a set of vertical angles. So let's go ahead and mark that as a right angle as well, since we know they're the same value. I'm going to then just take a look at the markings I have and see if I have enough information. I'm going to use the red here just to highlight this. Keep in mind, here's a right angle, so this is a right triangle. Opposite the right angle is our hypotenuse. Each of these guys are legs. Opposite the right angle is the hypotenuse. Each of these guys are legs. And I can see that by the HL postulates, because this is a right triangle, I have congruency. So I would maybe say, you know, can you prove it? Yes, I can, by the HL postulate. And again, I marked my hypotenuse in each one, as long as one leg in each triangle are congruent to each other, and we also have a hypotenuse congruent, we can use that postulate. Go ahead and pause the video and try to do 3, 4, and 5, and then check your work. All right, so you should have gotten the following for 3, 4, and 5, and I just want to point out a couple of things. Okay, so our pesky parallel lines have come back in our lives. We do show a mark here and a mark here, so we know those sides are congruent. But the parallel line marks helped me realize that I have alternate interior angles going on with this is my crosswalk, for lack of a better term, and my road going this way. I've got alternate interior angles, so it's important to mark those angles, and then at that point I can come up with a congruency statement. For number 4, you can see that I have a shared side, and that's nice and all, but I don't have a postulate called the ASS postulate. There are no bad words in math, so we don't use the ASS postulate, so this would not be congruent. So make sure you mark these sides, say the letters out loud as you're kind of walking through the path. If you don't find a postulate that fits, then you know you don't have congruency.